Hello मेरे प्यारे बच्चों and welcome back. I know, your exams are just around the corner and the tension is building up. But please, don't you worry one bit. This chapter, Elements, Compounds and Mixtures, it might look a little complicated, but trust me, we're gonna make it super simple today. I promise, by the end of this, you'll feel like a champion.
Okay, so to understand all this science stuff, let's forget the laboratory for a minute. Come on, let's go straight into the kitchen. Because you know what? The best way to learn science is to see it happening all around us, especially in the yummy food we eat.
Just look at this delicious plate of poha. You can see the peanuts, right? And the onions, the little pieces of green chili, the coriander on top, everything is just mixed together. But think about it, the peanut still tastes like a peanut, and the onion still has its own taste. They are all just kind of chilling together in the same bowl. And that, my dear students, is exactly what a mixture is.
So here's the most important thing to remember. A mixture is when you just, mix two or more things together, and each one stays itself. They don't magically change into something new. There's no chemical reaction, no pop or fizz that changes them forever. They are just physically mixed. Simple as that.
Now things get a little more interesting. Mixtures can be of two types. And to understand this, let's just stay in our kitchen and think about our favorite summer drink, shikanji. So look here. On one side, we have this healthy sprout salad. You can clearly see the different sprouts, the tomatoes, the bits of onion. Easy to spot everything. But now, look at that refreshing glass of shikanji. Wait a minute. Where did the sugar and salt go? You can't see them anymore, can you? It's like they've disappeared. They've mixed so completely and evenly into the water.
And that right there shows you the two types. The sprout salad is a non-uniform mixture, or the fancy word is heterogeneous, because you can see all the different parts. But the shikanji is a uniform mixture, or homogeneous, because it looks exactly the same from the top to the bottom. Every single sip is just as sweet and salty. See?
All right, now for something that might surprise you. We go to the market and we see so many packets with the word pure written on them. Pure ghee, pure milk, pure juice. But what does that word pure really mean?
For us, when we see a tin of pure ghee, we think, great, there's no milawat, no adulteration. It means they haven't mixed any cheap dalda or oil in it. And you know what? In our everyday life, that's a perfectly good way to think about it.
But let's put on our scientist hats now. For a scientist, is this ghee actually truly pure? The answer, and this is a really important point for your exams, is nope, not at all.
You see, in the world of science, a pure substance means it's made of only one type of particle. Just one. Ghee or even milk is actually a mixture of many things. Water, fats, proteins, vitamins. So to a scientist, it's a mixture, not a pure substance. Isn't that interesting?
So you must be asking, if milk and ghee aren't pure, then what is? Well, in science, the real pure substances are of two types, elements and compounds. Think of these as the fundamental building blocks of, everything.
Let's take the easiest and most important example, water, H2O. Water is a pure substance, and it's our best friend when we want to understand something called a compound.
Now this is where the real magic of chemistry happens. Just think about it. Water is made of hydrogen and oxygen. Hydrogen gas is explosive. It goes pop. Oxygen is the gas that makes things burn. You need it for any fire. But when these two combine chemically to make water, the new thing, water, actually puts out fires. It has completely new and different properties. How amazing is that?
So what exactly are these basic ingredients, hydrogen and oxygen? They are called elements. An element is the simplest form of matter. You just can't break it down into anything simpler. It's like the letters of the alphabet, the A, B, C, D. You use them to build words, but you can't break down the letter A into anything else.
So these elements, they combine in a fixed ratio, like always two hydrogen atoms for one oxygen atom in water, and a chemical reaction happens that bonds them together to form a compound. And just like you need a chemical reaction to make it, you need a chemical method, like passing electricity, to break it apart. You can't just take a strainer and filter out the oxygen from water, can you? Of course not.
All right, everyone, focus up. This next part is the most important question for your exams. The ultimate showdown, mixture versus compound. Let's get this crystal clear once and for all.
Now, you've probably seen this experiment in your textbook. In one dish, sample A, we've just mixed some iron filings with yellow sulfur powder. That's it, just a simple mixture. But for sample B, we took that same mixture and we heated it up.
A chemical reaction happened, and it turned into a new black substance. This is a compound.
Okay, time for a test. Let's bring a magnet near sample A, the mixture. What happens? Whoosh! All the iron filings jump up and stick to the magnet, leaving the yellow sulfur behind. Why? Well, because in a mixture, the iron is still just iron, and it keeps its property of being magnetic. We can separate them so easily.
But now, look at sample B, the compound. We bring the magnet close and nothing, absolutely nothing happens. The iron is no longer free. It is chemically bonded with the sulfur to become a totally new substance called iron sulfide. And this new substance is not magnetic at all. See? The properties have completely changed.
Okay, bachcho, this slide is your golden ticket for this chapter. Seriously, take a screenshot of this. It summarizes everything. Look at the differences. Appearance. In the mixture, you can see the iron and sulfur. In the compound, it's just a black mass. The magnet test works on the mixture, no effect on the compound. Adding acid. The mixture gives a gas with no smell, but the compound gives a gas with that horrible rotten egg smell. And finally, separation. You can separate the mixture physically, but you just can't do that with a compound. This table is the key to getting full marks on this topic.
Whew, okay. Take a nice deep breath. I know we've covered a lot, but you have followed along so well. Let's just do a super fast revision of all the main points, okay? No tension at all. You've totally got this.
So just remember this, a mixture is just mixed, like our poha or salad. Its parts keep their own properties. A compound is a totally new substance, formed by a chemical reaction, like water. The elements are the basic ABCs, like hydrogen and oxygen. And finally, you can separate mixtures by physical methods, like a magnet, but you need chemical methods, like electricity, to break a compound. That's it.
And before I let you go, here's a little something to think about. We eat table salt, or sodium chloride, every single day, right? But it's made of sodium, a metal that literally explodes if you put it in water, and chlorine, which is a poisonous gas. So why can we safely sprinkle the compound on our food? Think about it. It's the perfect final proof of everything we just learned.
That is all for today, mere bachcho. I know for a fact that you are all going to do wonderfully in your exams. Just study smart, stay calm, and please don't take any tension. You are brilliant and you will do great. All the very best.